Now we're going to do operations on nth roots. And when I say operations, I mean we're going to just review on how to simplify radicals. We're going to add and subtract and multiply radicals. Okay? Just as a refresher. To simplify the square root of 48, since this is not a perfect square, I know this is not a perfect square because I cannot find two numbers that I multiply by each other, exactly the same two numbers, and get a 48. The closest I get is 6 times 6, which is 36, and 7 times 7, which is 49. So this is not a perfect square. Still, I can simplify this by breaking 48 up into two factors. And maybe one of the two factors is a perfect square, and then I'm able to simplify this. So this is how we do this. When we have 48, what I do is I look for all the factors of 48. So I make a list. I write 48, and I make a list of factors, and I always start with 1. 1 times 48, that gives you 48, so these are factors of 48. 2 times 24, that gives you 48, so 2 and 24 are both factors of 48. And I keep going down the list. I like to go in order, that way I don't miss any of the factors, and I'm going to list all of them. When I have a 3, 3 times 16 gives you 48. 4 times 12 gives you 48. 5 times nothing gives you 48. 6 times 8 give you 48. 7 times nothing gives you 48, and then 8 times 6 gives you 48, but I already have those factors. 6 times 8 and 8 times 6 is the same thing. So when that happens, when I repeat a pair of factors that I already have on my list, that tells me I've reached the end of the list. That means I don't have to look for any more factors. I have all of them. So if I were going to make a list of all the factors for 48, I would say 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48 are all factors of 48. Okay, so once I've made up my list, I'm going to look for any factor that is a perfect square. Okay, let's see. 1 isn't a perfect square, 48 isn't, 2 isn't, 24 isn't, 3 isn't, 16 is a perfect square. So I'm going to square off the pair of factors where one of the factors is a perfect square. And I have another one here, 4 times 12, because 4 is a perfect square. Okay, so I have found, out of all these factors, I have found two pairs that contain at least one of its factors as a perfect square, 16 and 4. Now, this is what I do. I rewrite my original problem, I rewrite it as a product of these factors. Which one do I choose? Do I choose 4 times 12 or 16 times 3? I'm going to choose the biggest of the two perfect squares. So 16 is larger than 4. I'm going to use this pair. 16 times 3. 16 times 3. So all I've done is I've rewritten 48 as 16 times 3. But I have had the I was careful to pick a pair of factors that one of the factors was a perfect square, and also that this one was the largest factor, that was the largest perfect square. If you choose 4 times 12, it's okay, but you'll have to go through more trouble. Okay? So I choose the largest one, and I rewrote 48 as 16 times 3. And now, with the radical product property, I can separate the radicand in its individual radical. I can do this. This is perfectly fine. Be careful. Some students will do this. If you have 5 plus 4 and all of it is under the radical sign, this is not equal to square root of 5 plus the square root of 4. And you can check in your calculator. This one would be the square root of 9. So you can look for the square root of 9 in your calculator, see what that equals. It should, well, square root of 9 is 3. You don't need a calculator. I'm sorry. So this is 3, right? Square root of 9 is 3. And the square root of 9, if you look for the square root of 5 in your calculator plus 2, and you add these two up, you're not going to get 3. Okay? So that's how we know that we cannot do this. So be careful with this. If you have an addition or a subtraction, then you cannot separate them into individual radicals. Be careful with that. Okay, so back to our problem. I can separate them here because I have a multiplication. That you can do. And this is going to equal, let me write it below, not here. So the square root of the square, let me erase this very quickly. The square root of 16 is 4. And the square root of 3 is not a perfect square. I can't simplify it any further. If I break up 3 into its factors, the only factors are 1 and 3, no perfect squares there. So that tells me that this is simplified as much as it can be. So this would be my answer for the square root of 48 without a calculator. I can simplify it into 4 square root of 3. Okay, that's just an example. As a second example, what is the square root of 8 times the square root of 12? Okay, two things you can do here. Two things. You can simplify the square root of 8 like we did with this one, and simplify the square root of 12 like we did here by looking for all the factors of 8 and 12, and then multiplying the results. Okay, you can do that. Or you can multiply these together and get the square root of 96 and then find the factors of 96. I don't know all the factors of 96. I can try. It's going to take some time for me to find all the factors of 96. I have to divide a lot. So I'm going to work with these individually instead of uniting them and making them 96, because 12 times 8 is 96. Okay, so I'm going to do square root of 8. For 8, I'm going to list all the factors for 8. 1 times 8, 2 times 4, 3 times nothing, and 4 times 2. I have 4 times 2 already here. That tells me you've reached the end of all your factors. For 12, I do the same thing. 1 times 12, 2 times 6, 3 times 4, and 4 times 3. That means you're done. Now for 8, I only have one pair of factors in which one of the factors is a perfect square, 4. For 12, the same thing. I only have one pair of factors in which one of the factors is a perfect square. So these are the pairs I'm going to use to rewrite 8 and 12. So I have square root of 8 times the square root of 12. Square root of 8, I said I was going to rewrite as 4 times 2 times the square root of 12, which I'm going to rewrite as 4 times 3. Now I can separate these into individual radicals. This could be written as square root of 4 square root of 2 times square root of 4 square root of 3. And now the square root of 4 is 2. The square root of 2 stays as the square root of 2 because if I try to simplify it, I don't have any factors for 2 that are perfect squares. I only have 1 times 2 and 2 times 1. So none of those factors are perfect squares. That means this is simplified as much as it can be. Square root of 4 is 2, and again the square root of 3 is as simplified as it can be. And now I have this times that. When we multiply radicals, we multiply the coefficients. 2 times 2. These are the two coefficients. We look at the radicals, and the number that's in front, that's a coefficient. So 2 times 2, I multiply those together. That gives you 4. And then I take the radicals and I multiply those together. Square root of 2 times the square root of 3. And remember, by the product property rule that we discussed, not the product property, the radical product property that we discussed here, if I have a multiplication inside of a radical, I can separate them. But the same thing works when they're separated. You can combine them together under the same radical. So I can write this as 4 square root of 2 times 3. And that's going to give you 4 square root of 6. And there you have it. That's the answer. And you cannot simplify this any further because 6 has factors 1 times 6 and 2 times 3 and 3 times 2. And none of those are perfect squares. So this is just a review on how to simplify radicals. And on our next video, let's see. On our next video, we're going to do subtracting and multiplying binomials. I'll see you in the next video.